Hello everyone! Today I want to talk to you about generative design and how we can create generative design studies with Dynamo. So there has been a lot of fuss about generative design in the architectural world, whether or not it's useful, whether it's going to replace architects, what impact it's going to have on architecture as a whole. And if you want to learn a bit more about the backgrounds of generative design, I can recommend you my interview with Kian and Lorenzo, who the developers of the Refinery app that we're going to look into today. It's on my YouTube channel. I will leave a link in the description box. It's quite funny, so go check that out. And today we are going to look at the app Refinery itself and how I'm going to show you how you can install it, how you can use it, how you can create design studies with it. So let's jump right into it. Okay, so we're going to look at the software called Refinery today, which is essentially an app or an extension for Dynamo. So we start with Google, and the first thing you need to do is to type in beta Refinery, because it's not properly released yet. So here is that link, or I can put the link in the description box as well. So to the beta page of Project Refinery. And now what you need to do is to sign in with your Autodesk account. You probably already have one. It's the same email address and the same password for all of their websites. And then click on Getting Started. And here you find all the instructions on how to install how to install Refinery. You can just go step by step. It's not too complicated. Probably you need to uninstall your current Dynamo if you have the 2.1 version, but it's very simple. And then what's a bit weird is that once you install Refinery, you don't get a notification once the installation process is finished and it was successful. So don't worry about that. So once you've done all of that, you can go to either the learning resources if you want to learn more about generative design in general, or to the sample files. And then here you have different exercises that they put up for you with different problems, and that you can use to create a optimization study or a generative design study. So I would recommend you to download all the sample files, and the one that I want to look at today, the one that I want to go through with you, is this one here, the material cost one. So there is a building with a fixed volume. So I think in the example they put 300,000 as the volume. And then the length of the building, so this here, is 3 times the width of the building. This is the restriction. But the height can vary. And then you have one material that covers all of the facades of the building, so the sides and the front and the back. That costs $6 per square feet. And another material for the top and the bottom of the building, which is $10 per square feet. So it's more expensive. And now we want the program to find out what is the optimum length to minimize the total material cost for the building. So essentially, what does X need to be for this length, which then this length depends on, and ultimately also the height depends on it because there's a fixed volume. What does X need to be to have the smallest material cost possible? And I want to choose this example because we can also calculate the solution for this by hand, and I will show you later. So because it's that simple, I want to show it to you, because then we can see that the program actually works. It's always good to check to use an easy example first, so that we can better understand how it works and also check that the software works. Okay, so let's open Dynamo. Oh, but before we do that, I want to show you something else. So you can either open up Dynamo through Revit, like you know it, but you can also open it up directly, which makes it a bit quicker. And then it's called Dynamo Sandbox. And you have the file to do that on your computer if you go to your C drive. So my computer is in German, but I think the folder in English is just called program files. And then you go to your Dynamo folder, the core one, and then we need the X file, so just tap that into your search bar, and then here you have the file that you need to open up Dynamo directly, so you can send that to your desktop so you will find it again later. But yeah, this will execute the Dynamo sandbox without the need of opening Revit, right? Okay, so now we need to open from the sample files that you hopefully downloaded. We need to open up the material cost example. And what we can see here, it's not too big, it's a bit of explanation in the beginning. So this is essentially what I talked you through before. And then we have inputs, functions, and outputs. So inputs, as it says here, are the changeable variables. So behind every generative design study is a parametric model. So in this case, it's the model of this building, which is just represented by a block. And the model is parametric because there are some variables that can be changed. So in this case, it's the dimensions of the building, right? So what I called X before. So this distance here, which correlates with this distance and the height and the volume. So when I change this, all other dimensions change as well. And what I do here can also be done by the program. So can be done by Refinery in the end. So the optimization process goes through different values for this variable and then checks what results it gets from it. And the better the result, the more it will go into that direction. And how it evaluates each value depends on the outputs. So we got all of these functions, but what we get in the end here, the output is the calculated material cost. And in the Refinery program, we're going to say that we want to have the material cost as low as possible. So we want to minimize the material cost. So whenever the program tries out, so to say, a different value for the input, the cost gets calculated through this function here. And then what we get out of it is the material cost. And depending on how high or how low the value is, the program will decide how good or bad this value is. And in the end, offer you the best value possible. So what you have to do if you want to set up a whole new optimization problem is you have to provide a parametric model to the software. So this is done here, building a rectangular. So it takes this value here and then multiplies it to get a rectangle and then extrudes it by the height and then takes the surfaces from it, so we can so the program knows which ones are the facades and which one is top and bottom. And then the second calculation that needs to be done is the cost evaluation. So here we have the price, the material prices, as I said before, so the sides are cheaper than the bottom. And this is how the cost then ultimately gets calculated. And all Refinery needs are those inputs. And this is why once you installed Refinery, you can right click on a node, and then you will get here. So sorry, as I said, it's in German, but in English it should say is input or is output. So you can set a node to be an input so that Refinery knows that these are changeable variables. And here in the end, you can set this node to is output, so that Refinery knows that those are the values that are going to be evaluated. But since we look at this example here, this has already been done for us, and we just need to open up, we go to View, and then click on Refinery, and open up the Refinery interface. And then we can create a new study here. So what we want to do is we want to optimize something. And Dynamo already knows that we put something as input. So if we had various inputs here, we could select which one we want to go, we want the program to take into consideration. But since we only have one, we're going to select this one here, and our output is the material cost that we want to minimize. So here in the settings, this is what you can play with. So what we do in generative design is we create a bunch of different designs randomly at first and evaluate those. And based on their performance, the best ones are going to be evolved. So whichever design scored best are going to be taken into consideration for the next generation and are going to be developed further to gain even better results and better. And this is how generation after generation we're able to reach better results and find ultimately the best design solution for our problem. So the example I chose is very basic. But for example, if you have a site and you want to find out where best to place your house to get the most sunlight in each room, it would start and place the house in different directions and different locations, and like turn and move the house on the site, and just with each design approach will evaluate how much daylight each room gets. And then the designs with the best light would be evolved further and then get maybe tweaked a little bit into this direction or that to even get even more light in each room. And this is how you ultimately find the best solution to get most light into all of your rooms, which would have been very hard to do that by hand and without the computer. I mean, you can try and you would direct them towards south, the big windows, but you would never know if there is really the best solution. And what these three values mean is seed is how many designs you start with. So how many random designs it will start with in the beginning and then develop them further. So this is basically the first generation of designs. So this can be one, but maybe you would want to have a more diverse base for your study. So let's input maybe 5. And then generations is how long this process will keep going, how many generations it will produce. This is something you need to play with. This is different for each study. So basically you need to find out when the computer will hit the best solution for your design problem. This might be after 5 generations, this might be after 50 generations if it's a very complex problem. So the more generations you pick, of course, the longer the computer will calculate. So basically you need to switch it up a bit to see what results do I get after 10 generations? Do I get better results if I enhance it to 15 or 20 generations? And then you will see, so start low and then increase the number of generations if you're not satisfied with the results. And then population size is how many designs will be generated per generation. Okay, but enough of the talking. Once you set up all of this, you will probably get this issue that you have unsafe changes in Dynamo. So what you need to do is to minimize this and just to hit save one time in Dynamo, and then you're ready to go and can hit generate. And then you will see the computer calculating and generating all these designs. And voila, there we have our result. So what do we see here? First of all, here we see a little 3D model of the solution that it came up with. So obviously it's a rather high than large building because the facade is less expensive than the top and bottom material. And the exact value for it, we can see here, is 43 because it has the surface dimension, so what I called x before, on the x-axis, and then the material cost, the total material cost, here on the y-axis. And since this is a very simple problem with one input and one output, and so one obvious solution, it also only came to one solution. So in other studies that are more complex, you might have some various solutions with dots all over this with similar performance, and then you can pick and choose your favorite solution, knowing that they are all fairly similar in performance. But since this one has only one solution, this is the one that the computer found after 10 generations. And as I promised you, you can also calculate this, which I did. So basically what we have is we get one equation from the volume, which is 300,000. And then we get one function for the total price, which is the facade area times the price for the facade material, and then the top and bottom area times the price. And then if we do little calculations, and then we end up with this function, and then we want to get the minimum of that function, so we need to derive it and set the derivation to 0, and that we end up with the 43, which is the same that our refinery study has come up with. Only that in the refinery it wasn't calculated because of course the program isn't smart in itself. It has figured out this result, so to say, through trial and error basically. And if you want to just play with it a little bit, you can create a new study, for example, and just use less generations. For example, if we only give it 5 generations and start off with a value that is very far away from the solution, we will see that it might not have enough time in those 5 generations to come up with the right result. Yeah, see, so it gets close. I mean, we started with this large value, so the 5 generations brought it down to 48, but it's still not, it didn't have enough time to reach the best value, which would be the 34. So when you work with generative design, make sure to always try out different generation lengths, different amounts of seeds, different population sizes, to see if you can tweak the results a little bit and at what kind of value they stop developing. So enough of this example, let's maybe try something more complicated so we get some more interesting results, right? Okay, so I want to do that one here because that seems very interesting. So what we have here are these 6 houses that are being developed on a site. And now we want to position them in a way that they least block each other's views. So we want to maximize the views that we get for each of those buildings. And now if you open up that example in Dynamo, it's called views 2 directions. We can see right from the start that it's a way more complicated graph than we have before. So we have multiple inputs. So it's basically the position, x and y, so the xy coordinates for each of the buildings. And as an output, we have the total views that we get in direction 1 and direction 2. And now if we open up Refinery and do a new study, we can find all our inputs here, just like before, but we're going to leave them like we have. And then settings. So I want to start with, let's say 6 seats, and then population size and time generation is fine. And just like before, we need to hit save. And now we're ready to go. And as you can see, this time it takes a bit longer for the computer to calculate the results and to generate the designs. And when you look here now, you get all these different designs, but the computer is still running. So if you keep looking, you see that the designs are changing a bit in their positions. And now we're finished. So, okay, so here we have now all these different designs that we can explore. And each of those designs represent a point here on the graph. So you can look at this in the 3D view, but you can also check the variables that it got. So I would recommend you just to try that out, try out different exercises that they have on the website just to get in touch with the program. You have even here this other form of representation with these lines. So just click through the different options that you have if you want to learn how to use Refinery. So I hope you liked this video. I know you always want me to do more Dynamo tutorials, so I thought this would be maybe an interesting insight on something new that you can do with Dynamo. And since everybody's talking about AI and generative design, I just wanted to show you that with this Refinery app, it makes it very simple to just start small and like develop your own studies and your own optimization problems. And yeah, well, I hope you give it a try. I will definitely try and use it in the future, and if I find out something cool, I will keep you posted. So until then, have a nice day and bye bye.